Excellent. Good afternoon, everyone, and welcome to BUCHI's first webinar on unlocking ethanol's profitability, NIR, and raw materials to byproducts. I'm your host and one of the guest speakers today, Wade Hosnauer. I'm BUCHI's Business Development Manager of NIR. Here now I'm with our two fantastic people and resources, Mark Sullivan, NIR Application Specialist, and Isaac Kundo, NIR Product Specialist. Next slide, please. Before I get started, make a note of what we will be speaking on. Who is BUCHI, who we are, the process of ethanol and beyond. We'll be answering what NIR is, typical questions in terms of ethanol, ways to optimize the process, how to implement these solutions, and then of course, we have to plug the novel BUCHI products. Next slide. BUCHI has been around for a very long time, starting back in 1939, and with the first glass blowing workshops, it evolved into what you see today as the many solutions of rotary evaporation, Keldol, extraction, and NIR. Next, please. You've seen some more products being used in the nutritional facts labels on some of your freeze-dried foods, electrolyte packets, chicken cuts, and the COAs, or certificate of analyses, for wet cakes or dry distillers grains. Next slide. You may wonder, why is BUCHI in the NIR business and why are we so passionate about it? We've been working alongside some of the best companies in the world with applications beyond most NIR concepts. We found that BUCHI's NIRs are by far the most essential for fast and rapid detection of organic properties available in the market. Our more veteran and newer instruments reflect the needs expressed by those customers to fit an ever-changing need for flexibility and user-friendly quality solutions. So we are here now to show you more about the process and some important considerations our customers have mentioned. Next slide, please. Here's a good example from Penn State representing the dry grind ethanol process. While it's important to note the start to stop, many times research gets entwined in what's traditionally acceptable by standards. So for instance, you'll notice the primary products of CO2, ethanol, and DDGs, but they won't show you how it may be profitable to resell or quality check certain areas of that process. Next slide. For instance, what happens when you have too much ground corn? What if there's too much alcohol early in the process? How do you monitor your starch content? Can you resell wet cakes or DDGs? What about corn oil? Can we monitor that? What I'm trying to say is, don't let fear or tradition be your guide to your possibilities. BUCHI's here to work with you with the most bizarre projects to the most traditional. I'm not saying everything will work, but BUCHI is here to work with you together. With that being said, I have a quick poll question for all of you. The poll question, please. Has your company lost time or money to products being put on hold? I'll give you guys a few seconds here. I think that question might be out of order. All right. Perfect. So let's get back here. Can we show the results, or is that going to be at the end here? All right, so the quick poll question. The next one is, so what is NIR then principle? So some basics about the NIR principle can be simple. Light hits the sample and light is reflected, is measured. If you want to get real nerdy with me, then a more in-depth answer would be the incandescent light hits the sample diffuses, reflects light, which bounces off a stationary gradient, and then the intensity is recorded by a DAD or a diode array detector. Through calibration, the spectral data is quantified and predicted properties are displayed on the monitor. So in general, it's a little bit easier to say light hits the sample and light reflected is measured. Next slide, please. Here's a classic comparison that makes NIR worth your while. When I was nothing but a mere ethanol laboratory technician, I had no NIR. I would run multiple instruments for 10 hours a day with nearly no stop or break. My plant had a full-on laboratory where I had to run HPLC samples every 30 minutes for sugar and starch, moisture ovens every hour, 5 more drawn out live tests, and then I had to capture multiple samples for outgoing analysis. So it was exceptionally lengthy, time consuming, and very destructive. I was constantly using harsh chemicals like strong acids or bases, mobile phases for HPLC. Plus, I would always be maintaining, checking, and calibrating all the time. It was very exhausting. When I finally tried the NIR, it made 4 or 5 tests go from hours of labor to seconds. There were no chemicals to touch or inhale. It was simpler to work on, and the plant would actually appreciate reducing the sample use, reducing the operator's time, and then, of course, the laboratory time as well. After some calibration work, it makes life easier and would have definitely eased the number of samples being taken on a regular basis. So imagine the kind of work you can get done when you don't feel like you're constantly in crisis mode. Life is a lot easier. With that in mind, I have a couple more poll questions for you. Which best describes your company's revenue streams? Choose all that apply. All right, next question. Should be one more poll question on that. How many QC staff are in your lab? About 20, 30 seconds for this. Excellent. Next slide, please. So there are some considerations that I think are important when evaluating the NIR, and they're as follows. What is the environment? So for instance, is it cold? Is it hot? Are there falling objects all around you? Is it dusty? Is it wet? Acidic, basic, vibrating? Are you in production? Keep that in mind. How unique is your application? Is it a new grain type? Is it a regular measurement? Is it going to be in the field? Is it going to be a semi-milled product and not a fully milled product? Is it going to be mixed corn? Keep that in mind. Well, you need to clean your unit. So will you have to have the ability, go back to the slide, please. Thank you. Will you need to clean the unit? Spray down with cleaner? Do you need to wipe it down? How do you need to clean your actual unit? Can breakable glass be at the production floor? So for instance, different tools may require glass containers. Is that okay for your environment? Do you require networking capabilities? Do you want to have method unification from one site to another? Do you need results access? Do you need calibrations to be all the same? Do you need to connect every system here or in Denmark? Keep that in mind. And then last, do you want the ability to calibrate your instrument yourself, or have someone else do your own calibrations? And the reason why that's important is, does your company consider these calibrations intellectual property or not? Next slide, please. So why are these all important? Because when you're qualifying the NIR's company instruments, it's vital to get a solution which is truly your own and best fits your process. None of these solutions are black boxes. Salespeople may attempt to sway you into thinking that, but your purchase starts with that long-lasting relationship between yourself and the vendor. And these 6 points, the environment will tell you if you need something like an IP rating or resistance level. Application uniqueness may require a color or extended spectral range. Cleaning needs will tell you where the unit can be placed, near or against. And then again, glass, is it allowed on the plant floor? Does your company require any networking capabilities? And then last but not least, is your company's work your intellectual property, or are you okay with someone else having that? Without further ado, let me hand the next slides over to a wonderful person and excellent NIR application specialist, Mark Sullivan.
Thank you, Wade. So what I'd like to do is talk about how NIR can contribute to a production workflow. If we start from on the left-hand side, we would know that procurement will want to know about the quality of raw materials. Manufacturing will want to know if the process is running well. Quality control will want to know that the product is meeting specifications. And if we go even further, we can start delving deeper into can we measure additional properties like oil, if oil is one of the byproducts that we want to collect. And also, could we look potentially at the fermenter itself rather than just looking at the inputs and outputs? So all of these questions are viable questions for NIR. So let's talk a little bit about the idea of optimization for the process. In other words, doing things right, of getting your starch converted totally into ethanol versus trying to optimize profitability by doing the right thing. That is, by collecting the byproducts, which in this case might be oil, or it could be conversion of fiber, or optimizing the output as a feed for aquaculture. So let's talk about process optimization a little bit and mass balance. The incoming corn, of course, is going to have variable moisture and starch content. So we need to be able to monitor that to be able to look at the efficiency of the process. Ideally, as it shows at the bottom, 1 bushel of corn will generate 2.8 gallons of ethanol and 17 pounds of the dry distiller grain insolubles. So as long as everything's in balance, everything's fine, but the NIR can show when things start to deviate. So how do we implement this? Well, there are different ways to do that. If you had a benchtop analyzer, this is the conventional form of analysis, it would require you to bring the sample to the analyzer. The alternative is to bring the analyzer to the sample. And here we show a particular type of conveyor, which is full of corn, and there's an analyzer that's directly coupled into that production line. So these are the basic options. But let's think about this in terms of a scenario. So a scenario 1 would be that we have a benchtop analyzer installed in a QC lab. So let's talk about advantages and disadvantages of this arrangement. The advantages are easy installation for one. It's going to be just another part of your lab equipment. Access to primary techniques for calibration is another asset. And also already having an approval and reporting system within the QC department. The disadvantages? Well, production samples must be collected and carried to the lab. Second, lack of proximity, and of course, the abundance of other QC tasks may extend or delay the turnaround time. Next slide, please. So what's another possibility? How about taking that same benchtop analyzer and placing it directly into a production environment? What are the advantages of this? Well, similar to the other situation, easy installation. Now, the collection of production samples is easier because the person who's collecting the sample will also be doing the analysis, which means shorter turnaround time and the ability to do analysis on demand for critical events or for other kinds of troubleshooting. The disadvantages, well, you're going to have less technically trained instrument operators typically in the production area. And now you need to be able to protect your equipment since you're in a much more perhaps potentially dusty or wet environment, which requires a higher IP rating. So what about scenario number 3? This is the one where now the instrument is installed directly in the production line. Rather than having an operator that goes out and has to grab a sample, the product is being continuously monitored. And then the information is being fed back to a control room or to some other control station. The advantages of this, it's continuous. You get immediate process monitoring under all conditions. Alarms for atypical events or conditions will be automatic. And then the possibility for process control integration with feedback or feed forward type control systems. Disadvantages? Well, clearly this needs to be an IP rated instrument. It's a more difficult installation because you are tying directly into your process. And one of the other things that has to be borne in mind is that the QC lab analysis will still be required for periodic checks. Next, please. So let's talk a little bit about the heart of the matter here, which is NIR calibrations. The NIR calibration is the thing that allows us to be able to unlock these applications. NIR analysis speed, which we all want to and desire for the NIR, can only be gotten when the instrument is properly calibrated. And calibration can involve collecting a lot of different variations in your process. Could be in terms of what different feed streams you have, what seasonal variations, etc. But all of this, BUCHI has a solution for, working with customers to be able to develop. Calibrations do require ongoing updates. And that's what I was saying before, is that it doesn't remove the requirement to be able to do primary testing in a laboratory, but it does give us the speed that we need for high throughput. So what does a calibration look like? All right, so this is a calibration for starch. And the horizontal axis is the measurement of the starch content of the corn flour that's done by the primary method. Let's call that the gold standard. The vertical axis is the NIR prediction. In an ideal case, the calibration curve will be a 45-degree sloped curve, as you see here, with minimal deviation around that curve, which is what we do see in this particular case. So it shows us that what we're able to do is to replicate what the primary method is doing, only, as we mentioned, in a very fast and even continuous measurement online. But we don't stop there. We can do multiple analyses simultaneously, provided that we have the corresponding calibration curves for each of these, which in this case, we're showing the protein, which of course will be the important one in terms of the DDGS byproducts, fat, which again could be a potential source of revenue, and then also moisture in the final product. So with that, I turn now control over to my colleague, Isaac.
Thank you very much, Mark. Now, appropriate instrumentation plays a very important role in processing. I will highlight the BUCHI Proximate Benchtop NIR spectrometer, a suitable instrument for production environments in a typical ethanol plant. This IP69 rated unit can be washed down during cleaning in place operations with minimal risk to damage. The Proximate has an inbuilt Windows computer and comes with a touchscreen enabled interface protected by an FDA approved EPDMA sealing, in addition to the state-of-the-art sapphire glass light window. Now, the Proximate can be configured to have an up view setting where NIR light is directed and collected upwards through a sample container, or a down view setting where the light is focused and collected from the top surface of the sample. Better still, one unit can have both configurations. While the up view option has the advantage that a more consistent surface is presented to the Proximate, The down view mode offers the benefit that NIR light does not interact with the sample container. In an environment where glass is prohibited and plastic sample containers are used, down view is useful. Why is this important? Plastics have their own NIR spectra, which can influence the measurement output, leading to perceived shifts in your results. Moreover, down view also allows the use of large volume sample dishes, which are particularly useful with inhomogeneous samples, for example, corn, allowing the measurements to be averaged over a much larger sample area. This is a quick demonstration of approximate up view, where light is directed to the sample through a glass petri dish, and the down view mode with a large sample dish where NIR light is directed to the sample itself without any packaging. In both cases, the collection of NIR spectra is as simple as loading the sample, positioning it appropriately, and hitting the measurement button. One more thing, we measure color. Surprise! Speaking of options, the BUCHI Proximate can either be NIR only or have a combined NIR and visible spectrometer. Now, with a combined spectrometer and detector, it is possible to measure color directly using the visible region of the spectrum or as a calibration against a primary method for measuring color, e.g. the Hunter method. In addition to illumination options, the unit offers all three common metrics for color spaces, that is LAB, LCH, and XYZ. Now, color may provide useful insights into sample properties. For instance, in the LAB color space, a high L value in flour could be an indicator of low ash, while a low L value signifies the opposite. Now, in a typical NIR calibration development process, spectral data is collected and calibrated against reference data from a primary method to build a working model. This would require the appropriate software, but also an operator with chemometric knowledge. The BUCHI Proximate offers an auto-calibration feature known as AutoCal. This eliminates the need for a chemometrician or a modeling expert and saves a lot of the time needed to optimize calibration models. So how does this AutoCal work exactly? One, a sample spectrum is collected. In the NIR online setting, a grab sample is obtained via a sample loop or a sample thief. The sample is then sent off to a lab for primary analysis. The results are entered into the system. Calibrations are created or updated using the AutoCal function, which is activated by pressing one button. One more piece of good news. Proximates, multiple proximates can be managed from one central location using BUCHI's networking solution, NetCal. Known as Flux Console, this cloud-based software allows control and administration of a fleet of proximate instruments. The network administrator, through a web browser interface, can view measurement results, edit and deploy applications, and generate reports from a network of proximate instruments. Multiple users can be added to the same account with selected privileges. To wind down, we can all agree that analysis of raw materials and finished products is essential for process optimization. NIR can be a major part of this continuous improvement in efficiency. Compared to conventional lab techniques, NIR technology offers a fast and easy to use alternative for grain analysis. NIR measurements take seconds to yield continuous real-time results, when online systems are implemented, or frequent near real-time results when outline systems are used. In either case, there is support for quick decision-making when deviations occur. Nevertheless, it is important to remember that NIR is a secondary technique that must be calibrated against conventional lab techniques. So you still need your primary methods because it's not a complete replacement. However, it greatly reduces the need for primary analysis on a routine basis, especially once your calibrations have matured. Now here at BUCHI, our NIR calibration philosophy is to provide tools for the average user to create and maintain their own calibrations such that the calibration models are customized on the most relevant samples. AutoCal is a single keystroke operation that requires minimal training, and the customer, very important, owns their data and calibrations, and they do not need to pay a recurring fee. Remembering the scenarios Mark talked about earlier, BUCHI offers both benchtop and NIR online solutions for today and tomorrow. Outline benchtop systems are very easy to implement because they have a low initial cost, and they're also easy to move across plant and production lines. The good news is calibrations developed on the benchtop system can be transferred to the online system, and BUCHI helps with this process. Now, I think this is a good time to take questions and comments.
Any questions?
I think I see some coming in here. So this individual asks, usually how many samples are needed to create a robust calibration model? Would you like to take that, Mark?
Sure. Yeah, that's always a concern. So the idea is that a robust model, we've found from vast experience, requires something around 50 to 100 samples. And that's kind of a key indicator in that below that, you won't really have what we would call enough robustness to be able to handle a wide enough variety of samples. But in point of fact, you can actually determine whether or not you're getting a good calibration with maybe as few as 20 to 30. So let's just say for an analysis of this type in corn flour, where one is operating the plant on a daily basis and one is bringing in new kinds of raw materials, this is something that can be done in a relatively short time.
And while we still have you, Mark, someone says you talked about 2 different pathways for NIR implementation. Is it possible to transfer calibrations from benchtop systems to an online system? And if so, how would this be accomplished?
Sure. Yeah, that's an important point. So the idea is that each instrument has its own special characteristics. And one of the things that we do is to use a standardization system to be able to make them look more identical to one another. And this is something that's inherent when we're dealing with something like the proximate systems and the slides that Isaac showed, where these applications can potentially be deployed over a large number of instruments. So this idea of calibration transferability is something that is really crucial and inherently something that one does within an instrument line. I will say then that there is certainly the possibility to start out with a benchtop instrument to be able to do your initial calibration development. And then those calibrations can be electronically transferred to other instruments. But there are some caveats and limitations as to what kinds of instruments one can transport between. But in BUCHI's case, this can be readily done between the proximate and near benchtop analyzer and our near online process analyzers, because they basically use the same spectroscopy engine.
Wade, I think this is a good one for you. Someone asks, what kind of support does BUCHI offer apart from providing good quality instruments?
As far as services and what we offer, we go from anywhere between extended warranties, preventive maintenance services up to the full range of a complete priority deadline for assisting customers. And we're able to do that because we have local resources as well as a structured hierarchy for service in your area. So whether you're in the Northeast or Texas or let's say California, we have local service and support followed by application support and even phone support. So there is no lack of assistance and help and backup from our colleagues in the service team. They work with us alongside of us, and we also come up with solutions. So let's say you need a new system down the road, or you need a replacement part. We can help show the value between one choice and another. So there's no lack. We have local sources. We have account managers that are in your area, and we also have the service team members as well as application assistants. So you're not alone. We're here with you.
Great, thank you, Wade. I think the last two questions I have here, I can take one. Can the color measurement be a primary technique, or does it require an additional calibration? Yes, good question. With the Proxmate, you have two choices. You can measure color directly, because if you have the visible range or the visible spectrometer with your unit, you can have a direct color measurement, or you can calibrate against your primary technique. So for example, if you're using Hunter to measure color, you can calibrate against that to make sure that you're keeping in line with your old systems, so you're not completely dependent on the Proxmate, and you're not losing your old data. So yes, you can do both. You can measure color directly, or you can calibrate against a primary method. And the final question here is, if I have hybrids of feed materials, do I need to build a separate calibration model for each hybrid, or can I combine them into one regression model? Mr. Sullivan?
Okay, sure. I'll be happy to handle that one. So this is, again, a kind of a general question, and I'll maybe rephrase it slightly. And that is, can I use a global model which incorporates a variety of different sample types, or do I need a more localized model to be able to get better performance? So that's one of those things that has to be determined usually experimentally. And it also depends upon the requirements for a particular kind of analysis. If it's going to be a release test, then clearly one wants the test to be far more accurate and precise than it might be if it's a simple trending test for in-process analysis. So I hope I'm not avoiding the question here, but I'm going to say that it really depends upon the particular problem. And that's one of those things that BUCHI will work with the customer on to be able to decide which is the better route. Is it better to have maybe somewhat lower performance, but better, simpler ease of maintenance of a single calibration, or where high performance is required? Is it now a benefit to be able to break that up into localized models that have higher performance?
Thank you, Mark. And one addition I could mention here is, So while we have the auto calibration feature, we also have a chemometric software tool that can actually help us to go into models and optimize them further. And BUCHI usually helps customers with this process. So this is something we can help you with along the way. And with that, I'll hand over back to Wade to close us off.
Well, that's it from us. We really appreciate it. Thank you guys for joining. If you have any more questions, don't hesitate to ask us. We're not afraid to answer them. So you have our email, our phone number there. We really appreciate you joining. If there's anything else further, don't be afraid to ask. So thank you all very much. Hope you have a fantastic day. Again, I'm Wade Hosnauer, along with Mark Sullivan and Isaac Rakundo. Thank you for joining us.